All right, guys, welcome back to day 2 of our 1.2.2 lesson for Algebra 2. So we're going to jump right into it here. We're going to do what are called summary statements. You've probably done things that are similar to this in the past. It's basically just kind of saying, hey, here's the things which we know, and here's some justifications for those things for each part, for different types of functions or bits of info that we know. And we're going to be talking a lot about a lot of different types of graphs this year. So here's an example of a summary statement for a quadratic. So their statement is, hey, the function y is equal to x has a range of all real numbers greater than or equal to 0. Right? So their first justification is that you can see on the graph that the lowest point is there. Their second justification is on a table, so they produced a table of y is equal to x to the second, so how, hey, the lowest output u can get a 0. And then they also do it via the equation and trying to kind of solve it out and plug things in. So justifications, it's nice to kind of have those. I'm not really going to be big into formally having you write out a justification like you are seeing here, but that's a thing that it does help you to do. So I asked you to kind of do it kind of in your head, like, well, why do I know this? And as long as you can justify it to yourself, you're fine. I just don't like to force you to write things out. If that helps you, by all means do it. But for some people, it just kind of doesn't. So I don't like to force you guys to do things that don't help you on a personal level. Okay, so I'm going to kind of bypass number 82. I want you to kind of make a summary statement on the rational equations we did last time on day 1. So if you know that for whatever value h you chose, just kind of say, well, here's what I know about it, and here's why I know that. Here's my evidence from. Here's what it looked like on the table. Here's what it looked like on the graph. Here's how I kind of know what's going on with those asymptotes specifically. And then we're going to take a look at number 83. So this is the kind of crux of what can we take what we've kind of learned and put it together here. So if we have the problem 1 over x plus 25, what's that going to look like? Well, what we found the last time was that asymptote happened where we were dividing by 0. So the question is, well, what value x is going to make us divide by 0 for this one? Well, if x is negative 25, then I'm going to divide by 0. So I should see that kind of vertical asymptote at negative 25. So that's the first thing that I know. And then on the left-hand side of it, it should kind of slope down and follow down on that asymptote. And then on the right-hand side, it should kind of go up, follow the asymptote from that direction. So there's our kind of prediction. Let's go ahead and pull up Desmos and check out, see how close we actually are to that. We get rid of those, and then this needs to be plus 25, and then pull up Desmos. There we go. So here's the graph of that. If I go over to negative 25, which is like we predicted, hey, there's where we're seeing that asymptote happen. So our prediction was pretty darn good there. And that's, at this current point, what we first want to be able to say about these rational functions is, hey, they're going to have these asymptotes at wherever that h value is. And if we're fine with like that, at the current phase, that's all we really care about for rational functions. So with that, that's really all we have for today. So here's our notes on asymptotes. I want to spend a little bit more time talking about these because there are different types we've encountered kind of vertical thus far. Those are probably the most common ones. We can also have horizontal asymptotes. So the vertical ones are going to act kind of like walls you can't ever cross. You can follow them up or follow them down, but you can never actually cross through those. We can then also have horizontal asymptotes, and you're going to see one example of that right here, which we're also kind of seeing on our Desmos graphs, right? We actually have the horizontal asymptote kind of on the axis. You may not just not see it as easily because it's on the axis, but it is there. And those ones, oftentimes you won't cross them, but there are times when you can cross it. So like here on this one right here, we're crossing the asymptote, right? We cross it there, and we're crossing it a ton, but What's important for the horizontals is as you go further out to the right, we're approaching that asymptote. We're getting closer and closer and closer to it, just kind of wiggling back and forth though. We can then have what are called oblique asymptotes, or slant asymptotes. That basically just means that it's like not vertical or horizontal. So the one over here on the right is a slant asymptote. So it's kind of like actually at an angle here. There's also a vertical here, which you can also see. There's a slant one right there, which I have kind of dashed in there for you. But we can also have these oblique ones, which are things like even parabola. So here's a parabolic asymptote right there. Again, there's also a vertical one there. But as we kind of go out, we start to follow those asymptotes. Asymptotes are typically things that as you get to larger and larger numbers, they start to follow, right? On a vertical one, as you get closer to it, you kind of start to like follow. So it's a little bit different in that regard. But asymptotes really kind of tell you where things are going more than anything else, right? So those are the kind of main types. You may have seen these a little bit in the past. We're just trying to kind of get you more familiar, more comfortable with using these because you're going to be seeing these quite a bit going forward here. Okay, so with that, for our closure, just on your own here, just kind of say, how can you predict the shape of a graph if you know that h value for a rational function? So I'll think about that for a second. Now, if I were to give you the function 1 over x minus 20, what would that look like? Well, it would be that same kind of corner-looking graph thing, but the vertical asymptote would be at x is positive 20. Right? If you're able to do that, and that makes pretty good sense, you're exactly where you need to be for right now. So feeling pretty good. Here is our assignment for day 2. We're doing 91 through 97, and with that, I will talk to you guys next time.